Hello, this is Miraj Patel, and today we're going to be going over the last part of Unit 7, which is about molecular formulas, and then we're going to do a brief review of everything we learned in Unit 7, which was chemical composition or percent composition and empirical formulas. And so here we have molecular formulas. And so notice how, remember these three compounds, they all had the same empirical formula. Because if you remember, if you simplify that there's the same number of carbons and oxygens, but there's twice the number of hydrogens as the number of carbons or oxygens. And so the empirical formula is CH2O, so that's if we take the GCF and divide into all these subscripts, that's what we get. But molecular formulas are a whole number multiple of the empirical formulas. So this would be an example of the empirical formula, and this would be a multiple. This would be empirical formula times 1. This would be the empirical formula times 2, because notice how the carbon, there's 2 of them here. And this would be the empirical formula times 6. See how the carbon has 6 and everything's multiplied by 6. 6 carbon, 6 oxygen, 12 hydrogen. And so these are just multiples of the empirical formula here. And then we're going to learn how to calculate a molecular formula from empirical formulas. And so here, the question is, calculate the molecular formula of a compound with the empirical formula CH4N in molar mass of 60 grams per mole. So first, we have to know the formula, which is the molar mass of the molecule, the molecular formula, divided by the empirical formula's mass, equals the multiple of the empirical formula. So this gives you the multiplier that you're going to multiply to this thing to get the answer. And so first, we have to sort out our stuff. So we have the molar mass of the molecular formula, which it goes on the top, but we have to calculate empirical mass, and we get that by counting the number of atoms and sorting them out. So we have 1 carbon, 4 hydrogens, 1 nitrogen, and then multiplying the coefficients of these elements times the corresponding element's atomic mass. So if we have 1 carbon, it's 1 times 12.01, then we add 4 times 1.01 because that's hydrogen's atomic mass, plus 1 times nitrogen's atomic mass, and we add all this up and get 30.06 grams per mole. And then we plug this into the formula, so molar mass, which is right here, 60 divided by approximately 30, and we get approximately 2, and then we multiply 2 times the empirical formula, which is given to us, and FYI, the empirical formula will be always given to you, and so will the molar mass. So molar mass and empirical formula will always be given to you, and so all you do is multiply this multiplier to the empirical formula, and so you distribute the 2 to all the subscripts. So 2 times an imaginary 1 is 2. Then we get 2 times 4, which is 8. And then 2 times the imaginary subscript here, which is 1, is also 2. So it's C2H8N2. So that is the final answer, which is the molecular formula of this compound. And so here we have one more problem. Calculate the molecular formula of benzene with the empirical formula CH and a molar mass of 78 grams per mole. And so we want to find molecular formula, so we sort of do the same exact thing. So we have to first know the formula, molar mass, right here, divided by the empirical mass, which is given, gives you the multiplier for the empirical formula. And then we have to calculate empirical formula, or empirical mass. So we have 1 carbon, so we have to find carbon's atomic mass, which is 12.01, and multiply it by the number of carbons, and add it with the number of hydrogens times its atomic mass. So we have 12.01 plus 1.01, which is 13.02 grams per mole, so the empirical mass is 13.02. Then we put this in the formula along with molar mass, so 78 divided by 13.02 equals approximately 6. and then we multiply 6 times the empirical formula. So 6 gets distributed to all the different elements as subscripts. So we have a 1 and 1. So 1 times 6 is 6. We have 6 carbon and 6 hydrogen, like this. And so here's a quick quiz. A molecular formula can be the same as an empirical formula. And if you remember, we had one example, formaldehyde, where the molecular formula was the empirical formula times 1. So it's exactly the same. So the molecular formula was the empirical formula. So this is in fact true. And here's the same explanation. And so, for example, formaldehyde has the empirical formula CH2O, and it's the same as the molecular formula because the factor empirical formula times 1 is the molecular formula. So technically the molecular formula is the same because it's the empirical formula times 1. So anything times 1 is the same thing. And then here, question 2, determine the molecular formula of a compound with 40% carbon, 6.7% hydrogen, 53.3% oxygen by mass, and that has molecular mass of 60 grams per mole. So, if you recall from the last video, we did problems similar to this, where we had to find empirical formulas from the percent. So, if you remember the jingle, percent to mass, mass to mole, divide by small times to whole. And if you remember this jingle, you'll have no problem. So first, we have to convert these percents to grams by just getting rid of the percent sign and putting a little g for grams, like this. And then we divide by the corresponding element's atomic mass, which is from the periodic table. So carbon, we divide by 12.01 because that's its molar mass. Then hydrogen we divide by 1.01 because that's its atomic mass, and then we divide by 16 for oxygen. And then we put 1 mole on the top, so we have like a little conversion factor. So notice how 1 mole is at the top, and these grams will cancel out, and we'll just be left with the moles. Notice on all of them. So we just multiply these out, and then we get 33.3 moles of carbon, 6.63 moles of hydrogen, 3.33 moles of oxygen. So we divide by the smallest number, which is 3.33. We divide them all by that, and we get 1 mole of 1 carbon, 2 hydrogen, 1 oxygen. So this would be the empirical formula right here. Then we find the empirical formula's mass. So 12.01 is the mass of carbon times 1, which is the same thing, plus 2 hydrogens, which is 2 times 1.01, and then plus 16 gives you approximately 30, which is right here. And if you remember the formula, it's the molecular formula's weight right here divided by the empirical formula's weight, which gives you the multiplier. So you multiply 2 times the empirical formula. So we distribute the 2, so 2 carbon, and then we get, if we have 2 hydrogen, we multiply by 2, we get 4 hydrogen. And then if we multiply 2 times 1 oxygen, we get 2 oxygen. And so we're looking for C2H4O2, and the correct answer is in fact A. And so now we're going to quickly go over what we've learned on the last 2 PowerPoints of this unit. So first we have a quick PowerPoint on percent composition. And so we're just going to go through one problem, and I'm just going to talk about how we set it up. So when a 13.6 gram sample of a compound containing only magnesium and oxygen is decomposed, 5.4 grams of oxygen is obtained. What is the percent composition of this compound? So we have 13.6 grams, and that would be the total mass, and 5.4 grams of oxygen when we decompose it. So we want the percent composition of this whole compound. So we have to find the percent of oxygen and magnesium. So first, we look at the formula. So It's the mass of an element divided by the total mass, so 5.4 divided by 13.6, then we times it by 100. And that's exactly what we do, and we get 39.7%. And then, if you want to take a shortcut, you could just subtract this from 100%, and we'll get the percent composition of the other one. Because if there's two elements, if we find the percent of one, everything else has to be the other element. So that's how you can do this. Or you can just go ahead and calculate it. So you can do 13.6 minus the grams of oxygen. So we got just the grams of magnesium, which is 8.2, and then we divide that by 13.6 and multiply by 100 to get its percent. And notice these should always add up to 100. So a quick check step, you can just add these, and 7 plus 3 is 10, so we carry the 1. 1 plus 9 is 10 again, and then 3 plus 6 is 9, plus the 1 is 10, so this is in fact 100%. So this is correct. Then we have another problem, but this time we have to calculate the mass of the element and the total mass. So here we have propane, which is C3H8. The fuel commonly used in gas grills is one of the compounds obtained from petroleum. And so calculate the percent composition of propane. And so when they say calculate percent composition, we need to find the percent of everything. So we have carbon and hydrogen, so we have to find the percent of both of them. So again, we have the formula, mass of an element divided by total mass times 100. So here we have the calculations to find the total molar mass of this. So we have 3 carbons, so 3 times carbon's atomic mass from the periodic table, plus 8 times 1.01, which is a atomic mass of hydrogen, and we get this number. So that's the total mass that goes on the bottom of the fractions. Then we have carbon, which is, we have 3 carbon in this case, so 3 times 12.01 divided by 44.11 times 100 gives you 81.68%. And then we do the same thing for hydrogen, which is right here. So 8 times 1.01 over here, or 8.08, divided by 44.11 times 100 gives you 18.32 grams, or 32% of this whole compound. Sorry about that. And then we're gonna quickly talk about empirical formulas. And so we pretty much sort of talked about this in this unit. So I mean, this video ahead, back when we were converting from, percent to mass, mass to mole, divided by small times to whole. So it sort of includes empirical formulas. But just to go over, so empirical formulas are the smallest whole number ratios in atoms in a compound. So notice how in empirical formulas, there's nothing that can be divided even further. So these are the simplest numbers you can get of each element, but these are not. So these can be further divided down into the numbers on the top. So notice how 6 and 12 both are divisible by 6. So that's how we get this number. And 2 and 2 are both divisible by 2. So that's how we got HO. 2 and 4 are both divisible by 2. That's how we get this one. 6, 18, and 3 are all divisible by 3. And that's how we get these empirical formulas, which are the simplest ratios. And a quick way to know if it's empirical formula is if you see a prime number or 1, especially 1 at the subscript. So if you see no subscripts or you see a prime number, that means it's in simplest form. So if you see 2, or like if you only see 1 prime number, so if you only saw 1, 2 here, or if it doesn't work if there's like 2 prime numbers, but if you especially see no subscript at the bottom, that means it's definitely an empirical formula. And so here is a quick way to go from percent composition to empirical formula. The little jingle: percent to mass, mass to moles, divide by small times to whole. So if you sing this jingle, percent to mass, mass to mole, divide by small times to whole. So just remember this little jingle and you'll know exactly how to do these problems. So here's one more problem, or one problem, at least to practice. So we have this percent composition, so we follow the steps of the jingle to solve it. So what is the empirical formula of a compound that is analyzed to found to contain 25.9% nitrogen and 74.1% oxygen. So we do first step, percent to mass. So we just literally take off the percent sign and assume it's grams, like this. And then we mass to mole, so we divide by the molar mass. So we put 1 mole on the top, and then the molar mass of nitrogen on the bottom here, and then the 1 mole on top and molar mass of oxygen, which is 14.01 and 16. And then we get these two numbers, and then we divide by the smallest one. So 1.85 is definitely smaller than 4.63. So you both divide by 1.85, like so, and we get this number. We get 1 for one of them, and then we get 2.5, and then we times to a whole. So we multiply these two numbers so that they both become whole numbers. So if you remember, 0.5 is the same thing as 1/2. So if we multiply 1/2 times 2, we'll get a whole number. And so we multiply both these by 2, so that 0.5 goes away, and we get 5 oxygen and then 2 nitrogen. And this becomes the empirical formula, and that is it. So we have dinitrogen pentaoxide. And so that is a brief overview of this whole unit, Unit 7, which is all about percent composition, empirical formulas, and molecular formulas. And so most of it is all calculation. So for uh, percent composition, just remember to divide by the element's mass divided by the total mass times 100. And then for um, empirical formulas, just know that empirical formulas are the smallest ratio of elements, and if you see no subscript at the bottom, it's definitely empirical formula. Or if it contains only one prime number at the on the subscripts, which are numbers that can't be divisible by anything except 1 or itself. And then for molecular formulas, just remember to divide the molecular formula's mass divided by the empirical formula's mass, which gives you the multiplier you multiply the empirical formula by to get the answer. So I hope this helped you learn about molecular formulas and gave you a brief review of the whole unit. And so if you need any more help or need a more detailed explanation, please refer back to the separate videos. And the next unit is going to all be about chemical reactions. And so I hope you have a good day, and we'll see you later.